Now that we explored if statements, I want to talk about error handling. And for that, let me first of all clarify what I mean when I say error handling. Of course, you can have errors in your code, like a mistyped variable, that you should avoid at the point of time you're writing your code. Your IDE helps you with that and shows such errors. And even if you don't spot it there, if you run your program, you will get an error when you try to do so. So these are errors which you can and of course have to avoid as a developer. Simple typos and bugs like that. But there also are errors which you can't avoid as a developer. And we got a great example here in this example. We're fetching some user input here, and we are then parsing this as an integer. Now, of course, as a developer, we can't guarantee that the user will really enter a value that can be parsed as an integer. For example, here, if I execute this, instead of entering my age, I could enter max, which is not a number, and hence parsing this fails, and hence the program actually doesn't crash, but it also does maybe not behave correctly. You might remember that earlier when we worked on the body mass index application, when the user did not enter correct numbers, we got that not a number special type there. So the application there didn't show the correct result, and here it's just showing that else case message, but that is actually maybe also not what we want to do in such a case. If an invalid input is entered, like we have it here, we instead might want to show an error message to the user telling the user that the input was wrong. And these are kinds of errors in your code where the program then does not behave correctly that you can't avoid in advance as a developer because you can't control what your users will enter. And of course, that's just one example. You also could have an application that sends HTTP requests to some server, and maybe that server is offline, and therefore you don't get back a response. That would be another kind of error that you can't prevent as a developer. But you can expect such kind of errors. You can consider things that can possibly go wrong and then write code that should handle those cases when things go wrong. So for example here, when we're not able to parse that user input correctly because we haven't received a valid number, then we could handle that and show an error message to the user telling the user that the input was wrong, possibly allowing the user to enter the input again if we want to. And that's where this second return value comes into play. You might maybe know other programming languages where you have built-in error support and you can raise or throw errors if things go wrong. In JavaScript or Python, that is how you can, for example, handle errors. In Go, there is no such mechanism. You don't throw errors, you don't raise errors. Instead, in Go, you utilize the feature that functions can return multiple values to return error values as second or third or whatever return values that tell the caller of the function whether that function call succeeded or if something went wrong. And if we hover over parseInt, we can actually see that. Here we got a description of the return values, and we see that the first value is the integer. The second return value actually is an error thing. And if we read that description here, for example, we also see that parseInt may return errors that even tell you what went wrong. So here, instead of ignoring this second argument, we could give it a name of error or error. It's up to you, because you are still creating your own variable here. But error or error are typical names which are often chosen, and I'll go for error. Now, what is this error thing? It's of type error. But what is this error thing? Well, let's maybe just print it to the command line so that we can look inside of it. So here I'll print error. Now with that change made, let's start by running this again, and let's first of all enter a valid age, like 19. If we do that, we see that we get this nil output here. Nil, written like this, is actually a built-in value in Go that basically means there is no value. And it's used as a null value for certain value types. For example, a pointer that you created as a variable, but that hasn't yet received the address of a concrete value, would have a nil value. So it basically means there is nothing there. And that makes sense because we got no error here, because I did enter a correct number. But now let's see what happens if I do enter something that can't be converted to a number, like my name. If I enter that, then you see I get this error description here. And that's good to know. We get nil if everything worked, and we get some description otherwise. That means that if we want to show our own error message, that we can add another if check and check if error is not equal to nil. Remember, I mentioned that there is this not equal operator. If it's not equal to nil, then we know that there is an error. And in this case, we could show an error message with print line, where we say invalid input. Now, depending on our program, we could now prompt the user for input again, or we just stop the program, which we can do by simply calling return here. We are in the main function, and whenever you return inside a function, even if you don't return a concrete value, the function execution will stop. That is what the return keyword does. It's typically used to return a value, but you can always use it to stop the function execution. Because whenever you use return, the function execution will stop thereafter. Now, since return is used inside of this if check here, the function execution, and therefore our overall program here, will only stop if we make it into this if check. So only if we have an error. If error is nil, so if we have no error, we won't make it in there, and hence the function execution will continue and will make it down there. And that is how you typically handle errors in Go. You use this special error return value, and if that's not nil, you know you have an error, and then you can handle it the way you want. And therefore, if I now save this again, if we run this again, if we enter something valid, everything works. But if we instead enter something invalid, I get my error message and no other output because the function execution stopped.